This one, let's do a different color. If I had this, it means it does actually include that 5. Okay, so that's kind of what that means. Okay, so that's just a little reminder. Now, if we were to put this into words, okay, you would say x is less than or equal to 5. Okay, so that was how you would word that if you needed to explain it, say it out loud. So visually it's x with the crocodile with the line underneath it with the 5 on it. But if in words you were to do that, you would say x is less than or equal to 5. Okay? Okay, so how's that for a little quick review of that stuff? Hopefully you guys are okay with that. So now what we're going to do, excellent. So now what we're going to look at is when it's, most of you guys have seen that before. What we're going to do is when it looks a little bit different like this, and you might have seen this already. So -3 less than or equal to x less than or equal to 9. So I'll get you guys to write that down. And what typically happens is when we're talking about a number we don't know, this image right now, or this kind of linear inequality is showing that the thing we don't know is stuck in the middle between these two numbers. That's what that means. So it means -3 is the lowest it goes. It means it includes -3 because we have that line underneath, right? So it includes that -3. And then x goes all the way over to 9 and includes the 9. So x, whatever this magical number is that we don't know, can be -3, it can be -9, but then it can be any of those numbers in between there. So that's what that means, okay? So in words, you would say x is greater or equal to -3 and less than, or that's an or equal to 9. Okay? So that's how you would say that phrase in words. So x could be -2.999, it could be -3, it can be any of those, it can be -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It can go all the way up to those. It just can't go past 9, it can't go past -3. Okay? All right, and you will usually see it this way. You won't have the x written out here. You won't have the x over here and the numbers on the other side or anything like that. It'll always be in the middle, sandwiched in the middle, or it will be like this one over here with the x on this side and less than or equal to 5. That's typically how it gets written, okay? Okay, so that's, I'm going to leave that as kind of the reminder notes on inequalities, and that's what this little section is about, is inequalities, and then we're going to apply that onto domain and range when we're looking at how much does it actually go on the x and how much does it actually go on the y. So that's what domain and range is, so we're going to look at that. All right. Okay. We good? Everyone okay? So what I'm going to do now is, now that you kind of know how to write them and what that means, we're going to look at, I'm just going to draw quickly some number lines, and I'm going to show you where the points are, and we're going to talk about kind of what the inequality would have to be with that one. So we're just going to do an example here. So again, don't stress about your number line if everything is perfect or not. It's just generally what the point is. So 0, we're going to go 1, 2. I'm not going to number every number. Okay. So just quickly draw a little number line, something like that. Does anyone know why I'm not writing every number? One, it's hard on here. It's not always easy to write on the screen and reaching across and stuff. But what would be another reason why I wouldn't write all the numbers on there? There's probably 2 reasons. Yes, that's one. Mathematicians are lazy, so whenever you can cut out the work, definitely that's number 1. And the second, it would make it cramped. Exactly, Caitlin. So those are the two reasons. Oh, I just touched it. Those are the two reasons why we just don't write it there. Yeah, it gets really crampy, squishy, and then why? Why do I have to write those numbers down? I don't need to do that. Okay, so I'm going to put a dot right here, only a dot here. So if I asked you what x equals, what would be the inequality that you would write? So this one is a little different because it's not saying that there's a range of it. What is it saying x actually is in this one? X is, what is it? Yeah, x is -3, and that would be your answer. X equals -3. Okay, so sometimes you're going to get a number line asking for the domain of range, and it's going to be literally 1 point on it. Okay, we're going to do another number line. You're going to be drawing a few number lines here, guys. You're going to get really good at it. Okay. 0, 1, -2, -3, -4, 2, 4. Okay. I think for the most part we can keep using the numbers -4 to 4, so we can probably do a few of those. Okay. So this one, so it's the blue line. So if we look at that, thank you, Magical Merle. If we look at that blue line, what would be the inequality here? So we can see that it has a definite starting point, and it keeps going all the way to the other end. So does anyone want to wager a guess and see what you would write for this one? I know it might be hard with you guys. I don't know. I know the computer, your laptops and keyboards and stuff have the alligator symbols, but I don't have the equal tos. You might have to insert a symbol. I'm not sure, but yeah. Good. Thanks for the guess there, Cass. That's awesome. So we know that it's -3. We know -3 is being involved. And is it getting bigger than -3, or is it getting smaller than -3? So whatever the value of x is it getting bigger or smaller? Good. Thanks, guys. Yeah, definitely. It's getting bigger, which means that it's going to go this way. Okay, and because it is actually including that -3, it's going to be doing that. Okay, so x is going to be is greater than or equal to -3. So it includes that -3, but now it's going to be all the numbers front of that. Okay. Yeah, so like I said, I don't know, I think you can insert a symbol when you're, I don't know if you could even do it on Blackboard. If you, oh, there you go, Slade, perfect. What did you do, Slade, to get that to work, just so everyone else knows? Did you just insert the symbol, copy and pasted it, or did you actually use Blackboard as a way of doing it, or your keyboard? Let's see what Slade has to say about that. While he's doing that, we're going to draw a third one. Okay, so everyone draw your third guy. We're going to use the same numbers. Oh, you guys are figuring it out. Good. Excellent. Yeah, Jocelyn, yours is close, right? So it's just kind of just not matching, so that's good. Maybe we could do, yeah. The computer, yeah. Okay, so you're using something a little bit special to do that. Okay, perfect. Good, good. Okay, so everyone has the new number line drawn, and what we're going to do is figure out what this one is. So I'm going to do this. But I'm going to draw, I'm making this very exaggerated. It would not be that big. Actually, you know what? Maybe I won't do it that big. Let's do it what it probably would be. It'd probably be like that small. Okay. So this one I have not colored in. So I have not colored it in. So thinking about the inequalities, the other ones I've colored in. This one I have not. So it's going to be the same. It's still going to be x. It's still going to be greater than, and it's still going to be -3. But does it include the -3? If it's an open circle, does it include the -3? What do you guys think? Should I put a line underneath, or should I just leave it? Yeah, perfect. When it's an open circle like this, it means that it's not included. So it's literally -2.9999999. But it will never hit that 3, so it's an open circle. So that's why that inequality has no line underneath the crocodile mouth. Okay? And I'm going to give you one more. So you guys did well with that. So we're going to do one that's just a tiny, tiny bit different, and went with an example that I did too. We don't need to make this one as big, like so. And I will use blue again on this one. So I want you guys to try this one. So I'm going to put a solid dot there. I'm going to put an open dot here. I'm going to draw a line across. Okay, so see, this one definitely has a start and an end point range. That means the x value is in the middle. So it's in the middle, so you need to figure out what those two outside numbers are. So see if you can figure out, the numbers are easy, you can see what the numbers are. You know x goes in the middle because it goes in between those two numbers. You just have to figure out the crocodile mouth, what it is. Just give everyone a few seconds to see if they can come up with that. So we know the number is going to be -1 on this side. We know the number is going to be 4 on this side, and we know x goes in the middle. So what we need to do is figure out the alligator mouth. So because the x is bigger than the -1, it's going to be eating the x. And because it's less than the 4, it's going to be, whoopsies. One second, I went the wrong way there. It's going to go this direction because it's less than the 4. So now, which one gets the line? One of them, both of them, or none of them? Which one gets the line? The one in between, near the -1, or the one near the 4? Which one do I put, or both of them? Which one do I put the negative? Yeah, because this one is actually including it here, so I'm going to put it right there. But this one isn't. So the 4 is an open circle, so I don't need to be doing that. Yay! Good job, guys. Okay. Any questions on those? So those are just an example of when you look at a number line, a graph, whatever it is, just trying to figure out, basically, guys, what you were doing here is figuring out domain. That's what you guys were doing here. You were figuring out domain. So hopefully that's good. Okay. So, good, good. Oh, good. Okay. Let's see here. I'm going to do this one now. So this one is going to be a little different than what I've been showing. Actually, I'm going to make this a little longer. I'm going to make this one a little longer. We're going to start with 1, actually, and we're going to go all the way up to 11. Okay? That's a 1. 2, 3, 4, 5, 6, 7, 8. Wow, I totally did that wrong. I'm going to do this properly. Basically, go 1 to 11. I'm going to try to make it nicer just for you guys. So if I do 6, I can put 12 there. I put 0. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. There we go. There, that's a little better. Easier to figure out when you have the middle number in the middle. So, okay, so I'm going to give you this one, and I want to see if you can figure this one out. So this is going to stretch your brain, make you try it. It's fine if you don't know, it's all good. But I want to see if you guys can do this one. So I'm going to put a few numbers on here, just so it's easier. There we go. Okay, so here is it. I'm going to put a circle there, and I'm going to make it go this direction, and I'm going to put a solid circle here, and I'm going to make it go in this direction. Okay, so I want you guys just to see what you would do with that one. What would you get? So big hint, treat them separately because they're not joined together. So see what you would get for them separately if you did this. Okay, so this one, we have the 4, but the x is getting smaller or larger. Which one is the x getting in this one? If we look at the 4, is it getting smaller or larger than the 4? Yeah, it's getting smaller. It's going towards the negative side. That means it is less than. Now, does it include the 4? Yes or no? Does it include the 4? Should I be drawing that line there? No, it does not include the 4, so that's going to be that side. So I go over to this side. My x, is it getting bigger or smaller, smaller or bigger than 9? What is it doing? Is it getting bigger or smaller, smaller or bigger? Yeah, it's getting bigger. So we're going to have to acknowledge that it's actually getting bigger than the 9. Now, does it include it? Yes or no? Do I want to put that line underneath there? Yes, it does include the 9 because it's a solid. Okay? And guess what? All you do is put the word or in between them, and that's how that is the domain. That's the inequalities for that one. So when they're not kind of, if the x isn't stuck between two of them, if it's going out this way, then it's just an or. It's just an or, one in between. So yeah. Okay, so I'll give you guys a few seconds to just make sure you guys have that done. What you're going to do now is I'm going to give you guys some questions that I want you to do. I'm going to get you to write all the questions out, and then I'm going to give you guys some time to complete those sections, and then we'll come back and do them all. I wanted to put them on different pages so that when I give you guys the answers, the questions are there. So it's going to show up on 3 different slides of mine kind of thing. So just write all the questions out, and then we'll go over them, and then you can do them later on. Okay? You guys ready to do this? Okay. So here is the first one. Get you guys to write those down. So it says, I want you to describe in words is what I want you to do from A to G. Okay? So write those down, and those A to G, I want you to describe in words what that's actually saying. Remember, you're not doing the questions right now, you're just writing them down. I'm going to give you some time to do them, so just record the questions down as quickly as you can. And then I'll go on to the next one. You can record those down. Okay, can you guys put check marks up, please? Let me know if you are done. I'll go with the majority. I can always pop back afterwards if there's only a couple of you that are behind. But can you put a check mark on the screen letting me know that you got those recorded down? Again, you're not doing the math. You're just writing them down. So just a check mark saying you got those recorded. Okay, we're getting there. Okay, just a few more. Perfect. Okay. You're almost there, Kirsten, Sean. I can pop back to this one here in a second. Okay, so I'm going to go to the next one, and I can pop back to this one, Kirsten, for you, so you can grab that, okay? So I'll get you guys to write this one down. So there's 4 questions here. I want you to graph these on a number line, okay? So just like what we were doing, drawing the number line, I want you to show what this would actually look like, okay? So write these 4 down. You don't have to actually do them yet. Just write the 4 down. And then I'm going to clear the check marks, and then once you've done writing those 4 down, please put check marks in there again, please. Just these ones, yeah. just doing the number lines for 1, 2, 3, and 4. A to G, that was just writing in words. These 4, I want you to do a number line for them and show what they look like. Okay? So put a green check mark once you have all those written down, please. So we got one more I'm going to get you guys to do. And what I'm going to do on this next one, this is the screen we're going to stay on because I'm not going to, you can draw it out, but I don't think you're going to have enough time to draw it out and make everyone wait and stuff like that. So this next screen will stay on when we get there. Okay, so check marks, once you got all these down, you just have to write down 1, 2, 3, 4, write those things down. Okay. All right, so a couple more of you guys. All right, quickly, guys. You're writing down like 12 numbers and symbols. All right, so I just need Josh and Alexis. How close are you guys? Okay, Alexis there. Josh, are you almost done? Okay, perfect. Okay, so what I'm going to do is I'm just going to go back and show Kirsten. Oopsie, sorry. Oh my gosh, I gotta look at it here. Okay. Kirsten, just write down quickly what you need to do here. So what I'm going to do, guys, is I'm going to give you about 10 minutes. I'm going to show you the third page in a second, but I'm going to leave it up for you to do because you're going to have to actually draw a number line. Because what the question is going to be is take this number line and now tell me the inequality. So you're going to have to draw the number line just like we were doing. So that is, I'm going to leave that one up there. So Kirsten, I need you just to finish getting this written down, and then I'll go to the third one. Jess, what does the equal sign with the line? Oh, that means not equal. So if you have something that looks like that, that means it can't be that number or that thing or whatever it is. So if I said that Miss Mac can't be a whale, then it would mean I can't be a whale. I can be everything else, I just can't be a whale. Okay, so that's what that means. Okay, Kirsten, you got those written down? I'm all good. Just one question to write down. Okay. Almost there. Some of you guys can get started if you want while we're waiting. We're just waiting Kirsten to get this down. Well, you know, I just don't think I can live up to being a whale. It's a really big job. It's a big job. You gotta swim around a lot. I just don't know if that's my thing. I don't know. Don't got the speed, really. No, I just don't think I can live up to that. I know you could. All right, Kirsten, where are you at, my dear? You said one more to write down. I want to be a unicorn too. I wonder, have you guys seen like on Facebook where there's that picture of the rainbow cat with the unicorn and it has like Pegasus wings and everything? I'm like, yeah, that's what I want to be. Okay, Kirsten's done. All right, so here's the last one. This is going to stay up on the screen. You have to do 1, 2, and 3, and what you're going to do is write what the inequality is, okay? So the first page, A to G, you just have to write in words. 1, 2, 3, and 4, you have to now do it on a number line just like this is. And this one, 1, 2, and 3, you have to take the number line and write the inequality. So this is going to stay up. You guys have 10 minutes to do that work. Yes, eating 15 times a day, that would be awesome. Totally awesome. Okay. That is. Okay, so any questions on what you guys have to do in these 10 minutes? Okay, go. Bye. See you in a bit. You know what, it's fine, because we can just go and have the screen showing my PowerPoint too if you want to, so. Okay. It affects everybody here. May I share? Sure, Slade. Hi. Sorry, Slade just like threw up something here. He didn't actually throw it up. He just like typed it in. What is the extremely important announcement, Slade? What do you got for us? Oh my goodness, Slade. No, no, no. Slade, we can't. No, buddy. Sorry, we can't have stuff like that on here, okay? Yeah. So I can't have everyone reading this. How do I can't get rid of this, can I? Guys, we're just going to kind of ignore what's happening there. So Slade, sorry, this is not the forum to be doing that sort of thing. I appreciate you feeling the need to share, but it's just not the right time to be doing this, okay? All right, so let's go to our math. I need everyone to focus on this. Don't worry about reading that. I'm going to get us to focus on here. I wonder, I don't know. Okay. All right, so let's look at our examples here. I'm not going to stress about the wording part in terms of me writing it down. I'm just going to sort of say what's happening here. So right now we have x is less than. So you should say that the x is less than or equal to, I'll just put ET, ET, or equal to -4. So it's going to be on that less part. Salut, bonjour. Comment ça va? Okay, so this one, it's also the same thing. It's also less than or equal to. Okay, so it is the exact same one. Do you guys see how it's the exact same one? It's just they've put the variables in different spots, and because they did that, you have to change the way the alligator is facing. Okay, this one, x is greater than, but it is not or equals to, because there is no line underneath. So it's just, you're just going to say x is greater than -3. And then this is the exact same. This one is, sorry, it's not the exact same one. This one is less than. This one is less than. It's less than. No, it's not equal to, because there is no line underneath there, Angelina. So because there is no line, so this one here has a line underneath it, that means it's equal to. When there is no line here, so this one doesn't have a line and this one doesn't have a line, therefore it's not. For A, yes, that's what this means. Sorry, I just abbreviated. That's what ET stands for, equal to. That's what my ET stands for. That's my abbreviation. I don't understand why you didn't get that. You didn't understand ET meant that? Okay, so E, so you're going to say it is greater than, so x is greater than and or equal to -7, right? And then you're going to say it is less than, but not equal to, -3. Okay? And just have like a, you can say and, it's less than. Okay, so remember you don't have the equal to on that one. This one you say y is less than, can we say -7 less than or equal to x? Yes, you can, but you usually refer to the x because that's what we're talking about. That's the thing we don't know. So we just say x is. So we usually are talking about the x first. Okay? So here y is less than 18, but it's not equal to. And it is greater than and ET equal to -5. Okay? And then you guys already have most of this written down, so I'm not going to pause too long. So here it is greater than and equal to -1, and it is less than and equal to, sorry, that's an and, equal to 0. So that one doesn't have a wide range at all. So that one's basically goes from 0 to -1. So it's going to be all the decimal numbers between 0 and -1. So that one's got a small range, but it does have a range, right? So it's just showing, sorry, it has the domain because I'm talking about x's, or x, the y. So that, yeah, it's the range. Okay, so everyone cool with this? Anyone got questions about how to say them, how they should be worded? Anything? Okay. Good. So this one, I wanted you guys to draw number lines. So I'm going to draw a number line. I'm not going to stress about all the little notches. I'm just going to put the notches in that I need for this. So what this says is I have 4. There is no equal to, so it's an open circle, and it's less than it. So basically 0 is here, and that's 4. So that's roughly what yours should look like. Open circle going towards the negative numbers, and 4 should be open on there. Okay, this one, we have a range, so it means I have a start and end point. My end point is -7 on this side, and it's 0 on this side. And then in between there is where x is. So because there is no line underneath here, that becomes an open circle. This one has a line underneath, which means it's equal to, and then I just draw a connection line in between them. And if you want, you can throw in some other numbers in there just so you can see what you're talking about. Okay? Good, good. Goody gumdrops. Okay, this one. This one has an or, which means it's split. It goes like that. It means it has no middle ground. It goes from one end to the other. So I have a -2 and I have a 1. So those are my numbers, which means that 0's somewhere in there. So this one says, this part here says x is less than -2, which means open circle because it's not equal to, and it keeps going out this direction. And then this one is, it's a solid one because it's equal to, and it says it gets bigger than 1, so it goes out that direction. How many of you guys got that one? That one's a little bit of a little fun one to do because you have to do kind of 2 of them. How did you guys do on that one? Hopefully you guys did okay. Good. Nice. If you didn't, that's great. Totally fine. Now you're like, I see what happened. If you don't see what happens, ask me some questions, okay? Let me know if now that I showed it to you and you're still not clicking, just let me know, okay? And the last one. It can't be -1. So here's my -1. I'm going to put 0 in. So what that means is that I put an open circle like so, and it just does that. It's like flying. It's got like wings. So it can't be -1, but it can be everything before it or after it. Yeah. So hope that was a little different one. I always want to challenge you guys, right? Put one in there that maybe I haven't shown you, but you have to take what you've learned to and apply it. See if you can get that. If you totally didn't get it, that's totally fine. That's totally fine. Okay. Yeah, guessing is good. So it's why not, right? If you don't know it, you might as well guess it and see if you get it. So, and then the last, can I move on? Are we good? Are we good? Anyone need a few seconds? Are we good? 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 Okay, I'm moving. Yep, okay. So this one, we have to talk about the inequalities here. So because this is an open circle, that means that the alligator has no line underneath it, and the x is getting bigger. So it's going to be bigger than -6. If you did it the other way, if you went this way, oops, sorry. Actually, yeah, that's fine. If you did it like this, that's fine too. It's the exact same question, or exact same answer, technically. Okay? So this one has a range, so it's going to be, the x is going to be in the middle. It's going to be between 10 and 5. And because it's in the middle of them, the arrows, the crocodile mouth goes like that because it's less than 10 but greater than 5. And it only includes the 10. So that's the only one that has a line underneath it. Usually the variable, it depends. You'll see it both ways. Typically, you'll probably see this guy a little more often written like that because that is showing the end point, the -6, and then the x is going over this direction. That's probably how it would be written. And if it was going from this side, let's say it was going from the 2, if it was going from the 2, you'll probably see the x over this way because it's going this direction. So it doesn't matter. It's still the same answer. It really is. So if you put 5 plus 2 or 2 plus 5, it doesn't matter. So some people have preferences how they do that. And this one is an or. Or. So I am going to say I have to be getting smaller than the -1. So it's going to be, and it stops right there. So this one actually is really fun because I have, it's not just like going all the way to all the negatives. It actually stops at the -5. So it's bigger and includes the -5. But it's smaller than the -1, but it doesn't include it. And then this one over here, we can say that it is getting bigger. Whoopsies, I'm putting another x. I meant to put a 3. It is getting bigger and it's also equal to the 3. So that's how that one is. So that one combined that the idea of or, where you have two going different directions, but it also had in it had that inequality where there was a middle ground. So that one was like, boom, lots of good stuff in that one. Can you show number 1? Number 1 on this page, Jocelyn? It's up. Oh, okay, sorry, got it. Gotcha. Okay. All right, so any questions on these that you guys had to do on those bad boys? Okay. I'm confused on how you would know what is less than or greater than the x. So Angelina, so this one here, this is -3 and the number includes all of these, so it's getting bigger. It's getting actually bigger. Think of money. You have -$6 and now you start getting, you only owe -3. Now you only owe $3 and now you owe nothing and now you have $2. So you're getting more money. So because you're getting more money, you want it eating this. You want it eating that x, the value that fills in there. So it's always going to be eating the bigger stuff. And in this case, it's eating, it's the -6 is the smallest it's ever going to be. X is always going to be bigger than that. So it's going to be eating that. Does that make sense? Yeah? Yeah, I always treat it like money. What would you rather have? Would you rather owe $3 or owe $6? So if you owe 3, then that's the number you want to eat. Or would you rather have to pay someone $10 or pay them $3? You only $10 to eat that one. Or would you rather have 10 chocolate bars, 3 chocolate bars? You eat the bigger one, right? So always have the mouth facing wherever the bigger numbers are going to be. So Angelina, you're good? You say okay. I just want to double check. You're still okay? Good, okay. So now we're going to tie all this into domain and range. And believe it or not, this page here, you guys were doing domain and range here. You were actually looking at domain. Domain is always using x, like that, and range uses y's. Okay, so what we had there were domain and ranges written. You guys just turned it into words. So you guys have actually seen them already, which is really, really good. So now we're just going to kind of review them. So there are a few different ways that you can show domain and range. You can do it in words. You can show it in words. So you can say domain. So I'm just going to give you guys a whole bunch of examples how to do that. Domain is the set of numbers between 2 and 7. So you can write it in words. You can say the same thing about range. Range is the numbers between 6 and 12 or whatever. I'm not going to make you write both of those down. Okay? Another example would be you can say it's the domain is any number greater than 6, something like that. So just basically what you guys did on that first one is putting into words. That's number 1. Okay? The second one was the number line, which you guys have done. You guys did the number line. So I'm just going to show that briefly like this. That's a 2. Okay, so second way of showing domain and range is showing it on a number line. Third way is a list. Okay, so this one would be D, capital D usually stands for domain. And you put an equal sign, and then what you do is you do those funny little brackets that you guys have been using kind of, I think, since grade 7 or so. And when you do this, it could be a set of numbers, so domain includes things like this. And you close it off with the brackets. It can be like that. It could also be, you could say range is all real numbers, and I'll explain that to you guys just in a bit. Actually, sorry, that should be a Y. I know you're going to say, what is that, Miss Mac? I'll tell you that in a second, okay? And then you can do something called set notation. So, words we've talked about, number line we talked about, a list is just saying exactly with what it is that is part of the domain and range. And set notation is, it looks a little bit more complicated, but I'm just gonna show you guys what it looks like. So you say you're talking about domain. So that's kind of what that means. It says we're talking about X, we're talking about domain, okay? So then you say X, and this is where you write your inequalities, okay? And something like this. So that's sort of what set notation is. It's using the inequalities, which you guys have done. Do you have to write it like that every time? I'm not going to make you write it like that every time, but this, yes. This is the inequality that I was just, we were just working on, so you'll definitely have to write that. But am I going to make you write that X in the line in front? I'm not going to stress about that. That's not a big deal. But just so you can recognize it when you see it, so that if so you go like, oh yeah, Ms. Mac showed us that, that's what that means. We don't have to do that, but it's on a question or something like that. So I try not to get you guys too confused with that. All right, so when you do, okay, so what I'm going to do is sort of break this set notation down. So the brackets, these mean this is the set. This is all what's included in this set of things. So the brackets squishes everything into this set of items that we're talking about, okay? This line right here means such that. So remember in math, we don't do a lot of writing. We use a lot of symbols to represent things. So instead of writing multiply, we use an X, right? Instead of writing the word D-I-V-I-D-E, right? We do a divide symbol, stuff like that. So that's what this means. That line means such that. So here's the set, such that, and then it's talking about what your stuff is. Here, so this guy right here, I'm going to rewrite this over here. So I'm going to point out each what this means. So remember when we were talking about Surrey is a part of BC compared to, in comparison to, and all that kind of stuff. That's what this is kind of talking about. So this is an, what's an is? Element of. Again, I am just explaining this to you. Do you really have to know this in terms of what it means? No, but you have to kind of have just a general understanding of what's happening here, okay? And then this guy here, the capital R means real numbers. So when I say that Y is really a part of all the real numbers, that means it can be any number, is what it's saying. This guy here doesn't say X can be all the real numbers, because it can't. It has to be less than or equal to 5. Okay? So the domain has to be less than or equal to 5. So it has to go down, -4, -3, or 4, 3, 2, 1, 0, all that stuff. But with this one here, what this one is saying is that it can be all real numbers, meaning that it can be any number on the number line, as long as it's a real number, okay? So that's kind of what that's saying. So I just wanted to break that down. You are going to see this quite often, and you're going to be writing it quite often. So when there is no restrictions, so when the number, the domain or range, when it can be any number on the number line, that's what you write. And so this would be range, can be any all real numbers. And if you're doing domain, you would write it like this. Okay? So get used to that one because you're going to be using this one a lot and you're going to be seeing it. So when there is no restriction, so this guy here is a restriction. So that guy's a restriction because it says it can only be in this certain section, which is good. Sometimes that's the case. And then sometimes it says, nah, it can be whatever it wants. All right? So is that clear kind of there, what I was talking about? Are you guys okay? Does anyone have a question? Can I help with anything, Cass? You'll get the picture in a second. Like I said, don't focus too much about what everything meant. I'm just showing you so you guys have that background knowledge. But just know that you're going to get used to using the is a part of all real numbers. You're going to be using that a little bit more. Okay. So there is also something called interval notation. So this is another way of showing it, and you're going to be asked to show it a lot this way. You're going to show the inequalities. I might ask you just to put the numbers in the brackets. You might have to actually also do it as interval notation. So there are a few symbols you will need to know with this. So we're going to do the symbols and I'm going to show you. You have this kind of bracket. This means it ends at that spot. I'll just write that down and I'll show you what I mean in a second, okay? So that when you have a bracket that has that square bracket, it means it ends. When you have a bracket that goes like this, it's, sorry, don't put ends. It is included. It ends there, but it's included in there. So ends, and is included. Sorry, I just had to make some more space there. And ends and not included. Okay. And then you get this symbol. Does anyone know what that symbol means? It's a figure 8, but it's on its side. Then, yeah, infinity. Perfect. So that means no endpoint. Yeah. Infinity. So you need to know those because when you do interval notation, so you do inequality, there's also interval notation, which is another way of showing domain and range. And I'm going to give you some examples to show you what I mean. Oops, that did not, right, that's a G. There we go. Okay. So I'm going to give you some examples. So if I did this, -5 and 1. So notice it doesn't have the exact same brackets, and there's a reason why. So we're talking about the domain here. And so what this means, I'm just going to show you, this means it includes -5, and that's where it ends, is at -5, and it means it includes it. Okay? This means that it does not include 1, and this is where it ends as well. So what you did here was show the domain. I'll show you what the actual domain would have been. It would have been -5, it would have been 1, we would have had x in the middle. This means it includes it, this means it doesn't. So these two are exactly the same thing. So what we did was took this inequality and showed it in this interval notation. That's just a little different way of showing it. So the one would be an open circle, yes. So then if we drew this, good. So remember, so what we just did here, guys, these are all the different ways. This page is showing you all the different ways to show inequalities. Okay, so we did the words one, we did the words, we did the number line one, the list one you guys will get to know, and this is the inequality one. So now what I'm showing you is another one. This is like the 5th one, I think it is. So this is the 5th way of showing it. This was, I think, the 4th way of showing it, and I think this was the 2nd way of showing it. So you would have -5 here, you would have 1 here, this would be a solid circle, this would be an open circle, and that would be a line between. Okay? So yeah, so all interval notation is just doing it, showing it a different way of relating the domain and range to somebody, okay? So there's always a whole bunch of different ways, and the questions you guys are going to get coming up are going to be asking you to show them. They'll say show it as an inequality and show it as interval notation or whatever. So they're going to ask you to do it a few different ways, okay? I'll do one more here with you. I'm just going to erase, can I erase, oh here, I'll just erase this because this wasn't technically part of the question that I was doing with you guys. Okay, and I'll do one more question, just do one more here. If I had this, okay, so what this means is that -2 is not part of it, so I'm just going to show it as inequality. It means it's not included, and it means that it does not have an ending point. Okay, so that means that it's going to be every number, all real numbers from -2 on. So that would be the inequality for that one. Just so you guys can see what that actually means. Okay? All right. So when you guys actually start doing the worksheets on this, keep referring back to your notes on this. And just go, okay, close bracket or open bracket, what am I using? And go back and look at this one and go, oh, okay, it's going to be open. So please do that. Don't expect to have this memorized and remember this when you guys actually start doing your work. Go back and look at your notes and go, okay, what is the next part that I have to do, or what does that mean, or something like that, okay? So we're going to do this one together. So here what I have is I want you guys to find we're going to try to find the domain and range of this graph. So we're going to find the endpoints of this, okay? So we're going to start with the domain, and I have highlighted the green part. That is showing basically the front and end point of this, okay? So we have it going to -6. It's an open circle, so it is not including -6. And x is going in between these guys, and it says it's going to 7. Okay? Is it including 7? Yes, it is. So there is the inequality. So what I want you guys to do, I'm going to give you guys about 10 seconds. I want you to try and put that into interval notation. Okay? So using the square bracket or the rounded bracket, I want you to put that in interval notation. And it's just like an ordered pair, it just has 2 things in it. Oops, I can't do that. Not yet anyways. So if it doesn't include it, you guys should have a round bracket over here, and you're going to put -6, because that's the end point. The end point on the other side is 7, but it does include it, so you should have a square bracket on it like that. Okay? How many of you guys are able to see it, even if you got it wrong or didn't understand until I showed it? How many of you guys are kind of seeing what's happening there with that graph? Just put a check mark or whatever. How many of you guys are able to kind of see what's going on and see, okay, now I get why it's a square bracket, or now I see why it's underlined and not underlined and stuff like that? Okay? Okay, not bad, not bad. So here, the people that aren't putting check marks, if you're not putting it down because you're choosing not to answer the question, that's your choice. But I really, if you're not understanding it, please start asking me questions along the way. This is your time, right? I get this stuff. Merle gets this stuff, okay? But we're needing to do this for you guys, okay? So Jocelyn just asked a question. What is it specifically? Or is it just something you're going to have to work on? You're kind of getting it. I just got to do more practice. If that's what you mean by kind of, that's good. More practice, the better it'll start clicking in. But if you have a specific question, see if you can, I can help you with that. So now we're going to do range, and range is with the y's, right? So we're going to look at the y's. So here, this one, we have, shows a 7, and it shows it going to -4. So that's the yellow line, so we're showing that. So we're going to have -4 and 7, and we're going to put the y in the middle. So now all we have to do is figure out what the alligator mouths are. So if we look where it is at -4, it is actually including the -4, and it's getting bigger. This is getting bigger. We're getting more chocolate bars. We're getting more money, whatever it is. So y is getting bigger, and it's moving its way towards 7, and it does include it. Then as it gets to 7, It stops there, but it does not include 7, so it stops at 6.99999, whatever. Okay? I want you guys now, I'll give you guys about 10 seconds or so, I want you to change that into interval notation, please. Okay? So use the brackets. What bracket, how would that look? So you know your two numbers, so you can put the two numbers in there right away, and then all you have to do is figure out what is going on the other side. So because it includes it, you should have the square one next to the -4, and because it does not include it, it should be the rounded one. Okay? So hopefully that's starting to sort of ring some bells with you guys and going, yay, I'm kind of getting it, okay. More practice I do, the better I'm going to get at it, so that's awesome. Okay, so I'm going to give you guys, I think I'm giving you 2 questions to do here. I'm going to give you guys, let's say 3, the bells are being rung, ding, 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 ding. Okay, I'm going to give you guys about 3 minutes to do these questions. You do not have to draw these out or anything, just answer the question and go from there. So what I want you to do for A and B, I want you to tell me what the domain and range is in inequality. I'll give you 5 minutes. In inequality and interval notation form, okay? This one, again, remember I always tell you guys, I make you take the learning and apply it and kind of just take that extra step and see if you can do that. That's what B is. B goes, okay, let me look at this, see what we've been taught, and see if I can put it into this question that I haven't seen yet before. Okay, so that's what I want you guys to do with B. So everyone's going to try. I'm going to give you 5 minutes, inequality and interval notation. How do we know if we use the x-axis or the y-axis? You have to use both, because remember, range is y. Range is y. Range is the y-axis, and domain is the x. So that's what you have to use for that. That make sense? Yeah? Okay. So what I want you guys to do, you're going to find the inequality, and I want you to find the interval. I'm kind of saying that funny. I'm just realizing I kind of say that word funny. Interval notation. I think I do anyways. Okay? 5 minutes, go. Okay, welcome back. Have my grade 8 students next door. They're getting logged into Google Classroom right now, so I keep popping back and forth to see them. So none of them want to come and learn Math 10 right now. All right, so we're going to do look at domain and range for both of them, and then put them in inequality form, and then we're going to put in interval notation as well. So let's look at this one. So the key thing is, and I'm hopefully, if your numbers are off because you had a hard time seeing the graph, that's totally fine. But as long as you understand what you did. So we have to look at the endpoints here. So what this one ends at -3. This guy is at -2. And this guy goes all the way 1, 2, 3. So that goes to like an 8. And then go from here goes 1, 2, 3. So that's negative or positive 8. Whoops, what did I do there? Okay, so kind of just having an idea of where those numbers actually stop and start and that sort of thing is really important. And this one goes to a 2. So, okay. So when we do this, we're going to look at domain first. So we're going to have the x in the middle because it definitely has a start and an ending point. And so when we look at domain, we have, it's going the x value. So we're going to be looking from here all the way to here. That is the domain because it goes, we're looking at the x values. So it starts at -3 and it ends at 8. So what we're going to do with that is we're going to show -3 and we're going to show 8. And then all we have to do is look, does it include that number? Yes, it does, because it is a solid line here, which means it includes it, and it's a solid circle there, which means it includes that one. So that is going to be the domain for that one. And then when we do this, because it includes all of them, we do it like that. So you guys should have that for your domain. Okay? So a lot of times it's best if you put d equals so that you can tell the difference, because especially in interval notation, if I didn't have that d equals, you wouldn't know that I'm looking at domain or range. And then the range, so range goes from the bottom point, which is -2, and we go all the way up to 8. I know I'm supposed to be positive, but how about Caitlin, you just stop posting that, okay? I'd really appreciate that. So if you want to think the negative thoughts, I need you to kind of change them in your mind, but try to think positive, but just don't post that, okay? I'd really appreciate that. So with this one, so we're going from -2, we're going to 8. It includes -2, and it also includes -8. And because of that, we use square brackets. I keep wanting to make that -8 for some reason. I don't know why. Like that. Okay? So it's just a matter of seeing where it stops, where it starts, or where it starts, where it stops, finding the distance in between them, and then just knowing the difference between the square bracket and the round bracket. And the square bracket means it has more straight lines. You might help you to remember that. So this guy has the line underneath, like this, which means you should have more of a straight line. That might be a way of remembering that for you. Okay? So this guy, everyone okay with that one? Hopefully that one is just kind of reviewing what we've been doing. And this one's a little bit different, but possible for you to get that if you apply your knowledge with this one. So the y, we are going all the way from here all the way to here on the y. Yeah, good, Cass. It'll come. Yeah, so this is teaching. So everything is new and your brain is just getting used to this, and then you practice. And that's when your brain starts going, yep, starts picking up speed, right? So now we're doing the y, or the domain. And I'm going to do blue again. So d equals, and we do have a range. Now what I want to point out here, guys, is look at this. This says it does not include -2, but look at this. Here it includes -2, so -2 is part of it. Doesn't include 1, but here it does include 1. Doesn't include 4, but here it does include 4. So guess what? There is actually no gap between any of the values on x. It actually includes all of those numbers starting from -5 and goes over. It kind of is like a little piece of puzzle. It overlaps in another spot. So this one starts at -5. We have our x here, and it ends at 7. It includes -5, but it does not include 7. Oh, sorry, I'm up a little higher there. Sorry, Magical Merle is just going to show my stuff on the top there. Yeah, he's getting there. There it is. Okay. He's made me really big in the middle. I'm like, giant. Ah. Okay, So with this one, maybe just take me off the screen so they can see the graph too, please. So with this one, it goes from the -5. So it starts at the -5. It does include it. Goes all the way to 7, but does not include the 7. So that is why it looks like that. There we go. Perfect. And then because it includes it, has that extra line, I put that. And because it does not have that extra line, I do not put a square bracket. I put a round bracket. Okay? All right. It's like links. Yeah, Belle. Yeah. It's kind of like a little linky thing. And then the y is, now the y. This is the only part that I think is a little different than what we've been doing. And I showed you on this one here. This is sort of an example of what this question is going to be doing. So this question that I'm having you guys do here does not have a continuation, has very distinct y spots. So yours is going to be just a little bit different. What color am I doing y's with? So you're going to have r equals, because that stands for range. And guess what? It's very specific. So it is -3. It is -1. It is 1. And it is 3. Sorry, it's hard to see with my little line there. So that is what the actual range is. And because it's not an interval, interval means sort of like a portion of time or a portion of an answer. It's kind of like the amount of space that it takes up. Because this one is very distinct numbers on the graph, you can't do interval notation on this one. So the only answer would be the range is -3, -1, 1, and 3. That's it. That's the only spot on this graph where you will find any numbers on there. Okay, so that was a little different one, but that is taking what we've learned and going, yes, it doesn't have to be from 3 to -3. It can be actual pinpointed spots. So when you get dots on a graph, you're going to see it in this version a lot more. So if I have a dot here and a dot here and a dot here, you're going to see versions like this. You're not going to have this kind of stuff if it's just dotted. How do you decide if it's greater or less than? You have to look to see where the number is at. So if I look at this question here, what color can I do? This is the end point. X has to be bigger than this. Okay, -3 is the smallest that number is. It's getting bigger. I'm getting, now I only owe $2. Now I only owe $1. Now I owe nothing. Now I have $1. Now I have $2, have $3. It's getting bigger. That means that X has to be bigger than that -3. And it's eating it. Remember, we're talking about it has to eat the numbers that are bigger. Okay, so does that make sense, Jess? Okay, perfect. All right. So now what we're going to do is look at some linear functions, and we've talked about this already by being able to tell if something's linear or not, the ways you can tell if it is linear or not linear, no denominator, no x as an exponent, no squaring, all that kind of stuff. So what we're going to look now is, and you guys have done this before, we're going to look at linear functions because it can be treated like an input and output. It's like an alligator mouth, the alligator will choose, yeah, the bigger bird. I always say the more chocolate. It's kind of that kind of thing. So in this case, wow, I don't know what I was doing there. What we're going to do is make a table of values, and I think a lot of you guys have seen this before. So input is always the x, and the output is always the y. Is it always an x and always a y? No, it could be an m, it could be a p, it could be a d, but it's always going to be input is the one number on the left side and outputs or the letter variable on the other side. Okay, so what we're going to do is input numbers into this to try to find the output. So it's going to be like, if I eat this many chocolate bars, what is my output of boop? Okay, so we're going to do something like that. So we're going to pick some numbers here. So we're going to do 0 -2, -4. I'm going to actually give you the output, and we're going to try to figure out the input on 2 of these. Okay? So this is just review again, because this is things that you guys would have done prior to this. So what you do is you take the equation and you substitute in where you get the number for where you know what the answer to the variable is. So here it tells us x is 0. So what I'm going to do is substitute 0 everywhere I see an x. And in this case, there's only 1. Now you do the math. You go y equals 0 plus 1, y equals 1, boom, output is 1 if the input is 0. Okay? Then I'm going to do that again, and I'm going to substitute, sorry, I'll slow down. I just realized I'm probably going really fast. Okay? So when I put 0 in for the x, my output is 1. Yeah, you should remember it. It's algebra. It's kind of substituting in and out, input, output. So now we're going to do the other number. We're going to put in -2, and we're going to put it back into the same equation. So we get y equals, and these two are multiplying to each other, so we get -4, add the 1, and which team wins? Team negative wins, and they win by 3. So then I'm going to put in -3 here. We do this for 4. Like some of you guys can do this in your head. So if you don't need to be doing it this way, you don't have to do it this way. So then I go, let's do another one, y equals 2x plus 1. I'm going to substitute in the -4 plus 1. Okay, and if you can finish it while if you're caught up with me, you want to finish it, you can finish it. So then I do the math, -2, or -4 times 2 is -8 plus 1. They are fighting each other because they're on different teams. Team negative wins, and they win by 7 people. So now, the one that's different here, and I'm going to do this one in red, is it's different. Oh, sorry, I got to put the answer in. The reason why this one's different is I'm giving you the output now. So now you got to figure out what did we put in order to get that output. So you're going to write the question out just like you normally would, but you're going to put the number in a different spot because it says the output is 5. So that's, I put a 5 there this time. I know what the y is. I don't know what the x is. So then I'm just going to rewrite the rest of it. And now what I have to do is isolate the variable. I need to get that variable by itself. He's grumpy. He doesn't want anyone around him. So this is just a matter of doing opposites to try to get rid of it. And we've done this stuff already this year. So I need to get rid of this 1. So I do the opposite. It's plus 1. So I subtract 1. What you do to one side, you do to the other. So you end up getting 5 minus 1 is 4. And this disappears. That was the whole point of doing that, is to get that rid of it and move it to the other side. So now we're almost there. So what we need to do is see how to get rid of that x. So the 2 and the x are exactly, the 2 and the x are multiplying. So we just do the opposite. So I'm going to divide this side by 2. And I'm going to divide this side by 2. 4 divided by 2 is 2. And the whole point of doing this is to make that disappear. And x equals 2. And you put a 2 in there. Okay? So that is how you do it the backwards way. Basically, if you got the answer already, you got the output, what is the input? Okay? And then I'm just going to do the last one. So you get y equals 2x plus 1. The answer is 9. So I put 9 in. Rewrite the rest of the question. I'm going to subtract 1 from both sides. Those cancel each other out. 9 minus 1 is 8. Divide both sides by 2. And you get 4 equals x, which means the 4 goes over there. Okay? So that is just a review of previous input-output stuff that you guys need to make sure that you're able to do in this unit. So that's just making sure you guys are okay with that. So this part here are ordered pairs when it becomes graphing time. So if I took these, 0 in the x spot, 1 in the y. negative 2 in the x spot, negative 3 in the y, negative 4 in the x spot, negative, oops, I don't want to do that, negative 7 in the y, 2 in the x, 5 in the y, 4 in the x, 9 in the y. So when you do the table of values and find the input and output, you're also creating an ordered pair. And what those ordered pairs do is allows you to plot them onto a graph. So this is the step that you do in order to put stuff on the graph. So this is stuff that I even taught in grade 7. So these are the things that you learn how to put things onto a graph, is just pick numbers, find out what the input output is, and then that's your coordinate that you plot on there. So is everyone okay? Has everyone got that? I'm going to move the slide. Okay, good. Okay, so this can get shown onto a graph now. So what I did was took that table of values and plotted the points. So I'm just going to show you again. So for example, right here is 0 and 1. So what I'm going to go over here is 0 on the x and 1 on the y. And then here, let's say, for example, let's do this one, negative 4 and negative 7. So I go over here and go 1, 2, 3, 4, that's negative 4, and down to negative 7, and there's my dot. So each one of these was an ordered pair on the other page that we did, or ordered pairs that you can figure out. If one of those dots wasn't one we did, you can easily figure out what it is. So that is how you take that ordered pair, make them into coordinates, and then plot them onto the graph. Okay, so then what you can do is always as well double check that you did this properly, because it's really easy to make sure. And that's the one thing about algebra that's really awesome, is that you can almost guarantee you get the question right, because you take the answer, put it back in, and see if it works. So our equation was y equals 2x plus 1. We knew that, I'm going to use that negative 4, negative 7 one. We had negative 7 was the output, and we had negative 4 as the input. So what I'm going to do is take an answer I got. I'm going to take a set of coordinates, the input and output. I'm going to put it back in. I'm going to put it back in the question. What should happen is, and that's why algebra is cool, it's about balances. It's about, does this side balance with this side? So when I put those numbers back in, it needs to be balanced. If it's not balanced, something's wrong with my answer, and that's not a proper answer for it. So negative 7 stays on this side. There's nothing to do here. I go 2 times negative 4 is negative 8. I add 1. This side, there's still nothing to do. And then on this side, team negative wins by 7. Boom, done. Okay, so that's showing that the ordered pair that we got for it is correct. It is a point on that line. And guess what? That's the line. This is the equation of the line, and guess what? This is a point on the line. Okay, so that's what we were figuring out. Okay, we were using the table of value to find where that line actually goes, and when we find where it goes, it becomes a point on that line. Okay, good with that. Now we're going to relate this back to domain and range. Okay, which is going to be super cool, because this is where we get to use the part that I said you're going to use it a lot of. So I want you to look at that line. Okay, it's going to keep going, so I'm going to, it's just the arrows aren't showing. This line's going to keep going. Okay, it's going to keep going on this angle. I want you to think of the x. Look at the x and tell me, is there any number on the x that it's never going to hit? It's just going to keep going. It's going to keep going infinite amount of time. So is there a number that x, it's not going to hit on the x-axis? That's cute, Belle. Is there anything there? Well, no, it actually did cross the 0. This is 0 right here. So it did hit the 0. So it's hitting the negative 1, negative 2. So everywhere that it's along there. So believe it or not, this is the kind of line where you get that all the real numbers. So the domain equals x, all real numbers. It is going to be any single number that you can plug into this formula, into this equation. Any x value that you put in there, you're going to get an output, and it's going to be on that line. Okay, so that means that x can be any single number. It can be a decimal number, it can be anything like that, as long as it's a real number. And then the same thing with range. It's going to go up, and it's going to keep going up, and this one it's still going to keep going down. So r equals y is all real numbers. So this is an example that I was talking to you guys about, where you're going to have a graph that it can be any single number. So typically, a straight line that has a slight angle to it like this is going to be all real numbers. Okay? Does that make sense? Everyone okay? We good? So when you see a line that just has a slight angle to it, boom, there's your answer, right? It's always going to be all real numbers if it's like that. So that makes it quite easy to work with when you're doing that. Okay. So I'm going to move on there. All right. So we have this question. So what we're going to do is we're going to want to graph 3 points. So we're going to take what we just did, and now we're going to do it together instead of a teaching point. So what I want you guys to do is I am going to give you 3 numbers, and I want you to tell me what the output's going to be. Or don't tell me, don't literally write it up there, but figure out what the output's going to be. And then I asked you guys to print out one of the graph papers. I want you to then draw this onto your graph, okay? And I'm going to do that over here. I'm going to show, actually no, I'll show it here too for you. I'm going to get you guys to draw it on your graph. If you did not print it off, please start printing those papers off, because then you have a really nice grid and it works perfectly and everything's good. That's good. No, Caitlin, that's good, because you're going to need it further on in other units. And the more you practice in other worksheets you do, you actually might need more than that, but that's good. No, that's totally good. Okay, so I'm going to give you guys 1 minute to figure out the x, to find out the output, and then to plot it onto the graph, please. Okay, so go ahead. All right, I was getting a little head start here, just writing out the formulas. These numbers were picked specifically because it works really well with a fraction. So remember that this whole number means over 1. We're lazy in math, we don't put it. So when you combine those two fractions together, it's really saying -4 over 4. And when you do that and you do the division, you get y equals -1 plus 2. Okay? Sorry, Caitlin, they're all on the screen right now, so you should be able to see them. It might be just a glitch with your connection. And then when I do this, I get y equals 1, so the answer is 1. Okay? Then here, again, 0, any number times 0 is 0. Oops, that's a y. 0 plus 2, so you get y equals 2. And then up here, again, this is like 4 over 4 when we multiply the two fractions together. So 4 over 4 is 1, and you get y equals 3. Sorry, I'm just trying to keep that off the graph as much as I can. Okay, so that's how you figure out the numbers. So now what we need to do is now plot them onto the graph. So this is a coordinate, so this means -4 and 1. So I'm going to go to -4 on the x and go to 1. I'm going to put a dot there. This one is 0 and 2. I say 0, which means I don't move left or right, but I go up to the 2 spot, put a dot there, and this is 4 and 3. I go 4 on the x and go to 3 on the y, and then I draw my line and I put arrows at the end, like so. Sorry, my line, it should have gone through there. Like that, okay? I'm so masterful at my drawing on these screens. Okay, so what you just did there was found points on the graph, and you found points that are on the line that are on the graph. So here again, domain equals all real numbers for x and all real numbers for y, because it's going to keep going, and eventually at some point, for long, long ways away, it's going to do that. How do you get your answer with the fraction? So up here, what I was showing is this part right here, Alexis. So technically when you multiply, when you subbed in this -4, that technically means -4 over 1. Every whole number is over 1. So when you have, here, what color should I do here? So if I have 1 over 4 and I'm multiplying it by -4 over 1, when you use the rule for multiplying, you multiply the tops and the bottoms. So you get -4 over 4, and when you divide, -4 divided by 4 equals -1. And that's the same thing with the other one with the regular 4. Okay? Ah, yes, I get it. All right. So that is the first part. So now what I'm going to show you is a little trick that you don't have to pick a ton of numbers in order to figure out how to draw that line. So what I'm going to show you is how using something called intercepts will help you draw the line by only figuring out 2 things. Okay? So what we've done here is I've taken the graph, the better drawing of it, and I've taken the graph and I'm showing you where intercepts. Intercept, when you say you're going to intercept the play, that means you're going in and that's where you cross off with whatever, the football, the player, or something like that. Intersection is kind of where vehicles cross on a road. So an intercept is where it crosses. And when we say y-intercept, that means where it crosses the y-axis. Okay? Why does 1 minus 4, there is no 1 minus 4. Yeah, so it's not an E, Belle, but I'm assuming that's what you meant to say. That means that it means it keeps going on, and as it keeps going on, it's eventually going to touch every single number possible along the way. It doesn't have a stopping point. That line keeps going. Okay, so 1 over 4, because that's in the question. Sorry, Caitlin P. I'm not quite sure what you're asking me there. 1 over 4 was in the question and we were substituting in. Why does it equal -4? It doesn't equal -4. We're saying x does. So remember, variables are when we don't know what the number is. We don't know what x is, we don't know y is until we're told what it is. And guess what? I said, hey, I found 3 numbers that are on there. So you just get to pick whatever you want, whatever numbers you want. I think that's what you're asking me. Why was it negative? Why was -4? You can pick whatever numbers you want. I could have picked -600 and +3,000,002, but then you have to put that on the graph, right? So you want to just pick some numbers that you can use and do whatever you want there. So now what I'm going to show you, what I'm getting to here, is that you don't have to worry about picking any other numbers except 2 sets of numbers. So what I'm showing you is that the y-intercept is where that line crosses the y-axis, and the y-intercept, actually I'm going to change the color, sorry, the x-intercept is where it crosses the x-axis, okay? Now, when it does that, what I want you to notice, when it crosses the y-axis, right there, what do you notice about one of the numbers? And then when you look at when it crosses the x-axis, right here, what do you notice about one of the numbers there as well? Yeah, they both have zeros in there. So, when it crosses the y-axis, x is 0, because it has to be. On that line, on this line right here, x is 0. No matter where I put this dot, no matter where I put the dot, even if I put it in the middle, x is always 0 on that line, okay? And then if I look at this line here, no matter where I put this dot, no matter where I put it, y is always 0. I've not moved up and down. I've stayed on that x-axis. So when you are trying to graph a line, an equation, if you put in 0 in for the x, you'll get the number where it crosses, and you can draw that. And then put 0 in for the y, you'll get this answer, and then you can draw it there, and you have 2 points, and that's how you draw your line. You don't have to do 3, 4, 5 of them. You just need to do 2 of them. Okay, so I'm going to show you guys how to do that. Okay, so this one we're not going to worry about. We're not going to worry about that. We're just going to use. We could do this. We could totally do this. You guys can pick a whole bunch of numbers, put them on there. Guess what we're going to do? We're going to put in 0 for the x, find out the answer. We're going to put 0 for the y and find out the answer. And those 2 points are going to tell us where they cross the x and the y, and that's all we have to draw. So let's do this together. So I have y equals -3 over 2x minus 6. So that's our equation. So like I said, you can randomly pick whatever numbers you want to pick, input them, find the output, draw your line. We're going to do this to find the intercepts, and that's all we're going to do. So I'm going to put in, that's a negative. I'm going to put in 0 for x. That means we're looking for the y-intercept. We're looking for, if we're here and it says x, you don't move along this line, that means we're staying on that axis. We're staying right here. We haven't moved left or right. So when I do this, oops, sorry. So when I do this, I'm going to find that magical number. So y equals, what's nice about this, the answer is 0. We don't even have to worry about the fraction. So we get 0 minus 6, so y equals -6. So the coordinate for this is x is 0, y is -6. That's that magical coordinate where it is the y-intercept. Y-intercept. Where does it intercept the y-axis? Where does it cross the y-axis? So I go 0 and -6. This is where it crosses the y-axis. Okay? So that's what we just found out by just putting in 0 for x. We found the y-intercept. Okay? So does that make sense, guys, what we just found out there? Once you put 0 in for the x, you're finding the y-intercept. And now we're going to do it the other way. So now I'm going to rewrite the question. And this is going to be a good one because you can see how we solve a question when it has that fraction in it, just as a reminder, because I know we've done stuff like this before. So what I'm going to do now, I'm going to find the x-intercept, which means y is 0. So I'm going to put 0 in for this. Okay? So now what I need to do is just solve for x. I need to isolate x. Okay? So just like what we did earlier, I need to get rid of this 6. It's subtract, oh, I wanted a different color. It's subtracting 6, so I'm going to add 6. What I do to one side, I do to the other. Okay, hopefully you guys are with me. You guys good? Let me know if you have a question as we go along. So this side is 6. And the whole point of that was to get those to cross off. Subtract 6 plus 6 is 0. It disappears. It's gone. So now we have 2 and a 3. We need to get rid of that 2 first. It's in the ugly position in the denominator spot. What are the 3 and the 2 doing together? What are the 3 and the 2 doing together right now? Yeah, they're dividing. So what's the opposite of dividing, guys? Opposite of dividing. What is it? What is it? It's multiplying. So what I'm going to do to both sides is I'm going to multiply by 2. And what that does, this becomes a 12, and this magically disappears. So I'm left with a 3x. Okay? So again, this is just review. I'm not teaching anything new here. This is just reminding you of how to do these questions. And then I look at the 3 and the x. They're multiplying together, so I'm going to divide both sides. I can do divide by 3 like this if you want to. You can show it like that. Oh, sorry, yeah, it's negative. Thank you. I keep forgetting to put the negative in there. Okay? And so I'm going to divide by -3 because I want that negative to go away. I want a positive x. We're going to try to make this x happy. So I get -4 on this side, and I get x. So therefore, my coordinate for the x-intercept, where it crosses the x line, 0 is y. So it's going to be 0. So I don't go, I go to -4. Where is -4? I'm going to change my color. Sorry, one second. I'm going to do -4 here, and that is where it crosses the x-intercept. Okay? And then guess what? Boom! Draw your crooked line like Miss Mac does. That was a horrible line. Okay? And there's your line. It's done. So you could have done -6 and -2 and done 2. Guess what? Put in 0 for an x, find the y. Put in 0 for the y, find the x, and you found your intercepts. So there's your x-intercept right here, and here's your y-intercept right there. Boom, done. That is the straightest line ever. I know, I'm crazy like that. All right, okay. So that's all I wanted to show there for you guys, is how to draw these lines. So from now on, you could do a table of values. They might ask you to fill in the table of values and plot them on the line. Or they might say, using the x-intercept or using the y-intercept, find out how to draw it, or what is the answer, or what is it, okay? Yeah, I know, it's totally awesome. All right, where are we at? Yeah, okay. We're getting there, guys. So I am going to get you guys to do this one together. I actually combined a couple things together, so we're a little bit ahead, which is awesome. Okay, so I'm going to give you this. 3x plus 7y equals -21. Yep, you could do that. This is way easier because then I have to do less clicking. Remember, lazy math, less clicking. Just draw a line. It's crooked. You guys are like, yay, Miss Max. Totally messed up. So that's all good. Okay, what I want you guys to do, I'm going to give you guys 1 minute. You got 1 minute, and I want you to find the x-intercept, and I want you to find the y-intercept. Okay, ready, set, go. Okay, so got started here. So when you're finding the x-intercept, y is 0. And when you're finding the y-intercept, x is 0. So excuse me, I just had some water. You guys just need to plug those in, and then you just fill in the numbers after that. Don't put 30. Make sure you put in the brackets. 3 times 0 is 0. Plus 4y equals -21. Oh, thank you. So then I'm just going to, because I wrote the 0 in there, I'm just going to do this so it doesn't distract me. Okay, I did put the 0 in there for you, but now I'm not going to worry about it. I just want you focusing on the 4y. So I'm going to divide by 4, I'm going to divide by 4, and I get y equals -21 over 4. What did I know? No. What? 7. What did I do there? Why did I put a y there? Or a 4 there? Sorry, it's okay. Okay, we're going to divide by 7. That makes more sense. You guys didn't stop me. Holy cow. So I'm divide by 7, I get y equals -3. So 0 for x, -3 for y. This is the y-intercept. This is where it crosses the y-axis. Yay, we found it. Here, I'm going to write in everything else. Remember, put the 7 in brackets, or the 1 in 0 in brackets, doesn't matter. This is a 0, I'm not going to write it in. So we get this. Divide by 3, divide by 3. You guys should have done this, so I'm going a little faster. Therefore, -7 is the x value, 0 is the y, and this is the x-intercept. Boom, done. So then what you would do is probably plot those 2 points and then draw your grid there. Or they might just say, what's the x-intercept, what's the y-intercept? You do the math, you don't have to actually draw that, okay? All right, cool. So, yeah, so what I want to show you, sorry, I'm a little ahead of my my pretend notes. So what I'm going to do, let's do this. We're just not going to worry about this question. What I'm going to do is draw a little graph on here, and I want you to tell me what the x and y intercept is. Okay, so I'm going to draw with my lovely straight line, Caitlin T. I'm going to put that one there, and I'm going to put that one there, and there is my line. Again, it is beautiful. I want you to tell me what the x-intercept and y-intercept is. Okay, so all you have to do is just do something like this, and then tell me what the coordinates are. Okay, so this guy right here, x is 0 and the y is 4. That is your y-intercept. You'll see it written a lot like that, y-int, short abbreviation. And then this one, I move to the -2 spot, and it's 0, and this will be your x-int. Good. Thanks, Cass. So yeah, so sometimes they'll give you a graph and say, tell me what the intercepts are. And they're right there for you. Or if it's hard to figure out, let's say, yeah, let's do that. I'm going to show you. I think the next one I have a picture. Yeah. Okay, ignore that. So, oops, throwing my pen everywhere. Let's say it crosses right here. Do you see how it's kind of crossing? Yeah, thank you. It's not crossing actually at an intersection point of an x and y coordinate. And so you have a graph and you're like, oh my gosh, I can't tell. And let's say it crosses like this. So it's got a weird crossing spot. And the graph is like, what is the y and x intercept? I can't tell. Guess what? Then put in 0. So if it was y equals 3x plus 2, put in 0 here. And then you'll get the answer. And then put 0 in for y. And then you'll get your answer. So when it's when they give you a graph and you're like, I can't tell, I can't see it, then take the equation, put in 0, and then just do it the other way. So sometimes even them giving you a graph, you might actually still have to do the math, because math is fun. It's awesome. It's awesome. Everything is awesome. Okay, so last thing that we're going to look at today is looking at something called discrete, not discrete kind of stuff. And we're not going to focus a ton on this, but I believe when your homework has a question on it, just in case that there's a question on it so you can understand. So here is our equation. And the story is C is the cost in money, in dollars. And you're renting a hall for a dance. You're going to dance. And so N is how many people are coming. You don't know how many people are coming at this point. And you're going to charge them. What this means here is for every person that comes in, they're getting charged $4. Can someone tell me what this one means? Why is there an extra $100 added on? What would that be? If we're looking at, we're renting a hall, we're charging $4 per people, what would be that $100 that's added on? And it doesn't increase. It doesn't increase. Good, thank you. Cost of renting, thank you. So no matter how many people come, it's always $100. It is basically probably rental of the hall. So no matter how many people come to this party, Okay, if it's like a dud and only one person comes or no one comes, or it's amazing and 1,000 people come, it doesn't matter. Whoever comes to this party, it's going to be $100 for the hall. Then you charge that $4 per person. Yeah, it could be a charge for the room. It could be whatever they want to do it. So what we're going to look at is we're just going to look at identifying the dependent and independent variable. So remember, dependent always needs to know what's going on with the independent. We're going to graph what it would be for 500 people to come. And then this is just asking what variables on the x and if this is discrete or continuous. Okay, so we're going to talk about this. So what you could do is you can make a table of values to draw this, and you can say, okay, let's make it so that 100 people come, and let's make it 200 people come, and you can start figuring it out that way. All right, there would be. So all I could also do is say, well, let's just take the equation and figure out what it would be if 100 people came. So people is n. So it's going to be 4 times 500, sorry, plus that. Okay. So I get 2,000 plus 100. So this is how much money I would, whoopsies, that is how much money I would make if 500 people came along, okay? And that's how many people come. Oh, it's a party. We're having a party. Yeah, I'm going to sing, and it's going to be amazing. There's going to be like teddy bears to cuddle, and there's going to be kitty cats to pet. It's going to be a party. Okay, no, I'm just kidding. Okay. You can't have a party. You're not even here. Not even here. Okay. We'd make, wouldn't you only make, well, this is how much it would cost for the, this is how much it would cost. That's the total cost. I would pay out, that's what it would cost for me to have this party. Because every person that comes, it costs me $4. They have to pay the $4, and then there's a hall cost. So it's kind of like that. Yes, we could FaceTime you. Yeah. So that is just roughly how you figure this out. So when you go to draw this, the number of people affects the cost. So independent is going to be the number of people, and the cost depends on how many people come to this. So that's just the difference between the x value is always the independent variable, and the y-axis is always the dependent variable, okay? So you don't have to really focus on drawing this too much, but you just need to understand that whatever is dependent goes on the y, because the cost really has to, how many people come really affects the cost of the party, okay? So that's why one is on the x and one is on the y, okay? And then this is graphing it for how many people were coming. So then you would use a table of values to help you graph this and figure out where it goes. I'm not going to make you guys do that, but this is what it would be. So you would, like I said back here, you would do this, okay? You would sit there and go, okay, if I have 100 people coming, what's my cost? If I have 200 people coming, what's my cost? And then I just showed you what it would be for 500, and then you would come here and you would graph it on your line, okay? So now the question is this discrete or continuous? Now, please ignore the fact that there is a straight line. The reason why there's just a straight line drawn through it is just to kind of connect the points and see how it works. But discrete basically means it has to be specific. I'm going to kind of try to put it into words that kind of make sense for you guys. So it means it has to be specific. So when we think of this, can I have 100.2 people coming to this party? Can I have 100.2 people? No, that makes no sense. So it means it's very specific. It's 100 people, it's 101 people, it's 102 people, it's 103. So it's very definite spots along the way. When you do a line like this, if I was talking about cake, let's say I was talking about cake and the cost of cake. Can I have 100.2 of a cake? Yes, I can. Or 100 cakes, 0.2 of one? Totally can. So that would be this, if I had a cake question, this would be continuous, because I could have, oh, I just moved that. I could have numbers fitting in between all of these little tiny spots. But this question is discrete because it's very specific. But she's still a whole person, still a whole person. We're not talking height, still a full human being. So that's the difference between discrete and continuous. Discrete means that it has to be specific things. You can't have sort of in between numbers. And it's usually more dot, 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 dot. Continuous means you can have those in betweens and it continues on anywhere along that line. So I just wanted to explain that to you. So discrete is very specific and continuous can be anything. Can be any. Whoopsies. It can be anything. Sorry, I moved that. Okay? So that's all I want to say about that. There's nothing else I want to talk to you guys about that. So, last thing is this one. We're going to look at rate of change. Seriously, last thing. We're almost done. We're almost there. Rate of change, you are going to need to know this. Okay? And what it is just showing the difference between one point to another. It's just how much did it change from here to here. Okay? This is not going to be a mind-blowing lesson point. It's going to be, oh yeah, well that makes sense. Okay? So for example, if I'm using this point here, I'm going to look at how did the y change and how did the x change from here to here. So I'm going to look at how did this actually change. So I'm going to look at the value of my y, and notice that this is by $100. So it doesn't mean that it's 9, it means it's 900. So my first point is 900. I went from 900, and how did it change going down? And it went here to 500. So that's how you show rate of change between those 2 points. And then the x value is 200, and then it changed to 100. So this is all rate of changes. It's taking the y values and putting them, subtracting them, and then taking the x values and subtracting them. So when I subtract them, I get 400 over 100, which equals 4. Okay? So the rate of change is 4. And I'm going to show you this. This is the example of the haul. This is the haul example right here. How much did it cost per person? How much did it cost per person to go to this pâté? Pâté! Yeah, it cost them $4. We just proved that that's correct. The rate of change, how it changes, one person added, $4. One person added, $4. One person added, $4. That is showing how this was created. So you are going to be asked about rate of change. That's why I want to make sure you guys understand it. It's just taking the y value and subtracting 2 points together, and taking the x value and then subtracting 2 points together. And some of you are going, oh, Miss Mac, but what happens if I did 500 subtract 900? And what happens if I did it this way? What happens if I didn't start with the bigger number? Guess what? You still get the same thing. You get negative 400 over negative 100, and we know a negative divided by a negative is a positive. You still get the same answer. Same answer. So it doesn't matter which one you put first. It doesn't matter if you put this guy first and subtract that one, or it doesn't matter if you put this guy first and subtract the other one. It doesn't matter. Okay? I know, I'm very good. I'm an impressionist. Actually, my husband makes fun of me because I cannot do accents. He says he goes, no, I think I'm actually talented because I am able to take 3 accents and put them into one. That's how good I am. But yeah, it just randomly happens. I cannot do accents at all. Okay, so we're done. Here is what you guys need to do. There is going to be lesson number 3. You have to hand in. It's asking domain and range, if it's a function. You have 4 questions to do. Now Thank you, Miss Mac. You're so awesome. It's only 4 questions. Okay. And then this one is looking at more the domain and range part of it and trying to find points on the line and using the x-intercept and the y-intercept. And there are 7 questions on this one. So you guys have a whole total of 11 questions. Both have to be handed in for me. Okay. So okay. So test reminder. You guys have to do your test. Due Friday. You have to do it by Friday. 2 days have gone. You got today, Thursday, Friday. Today, Thursday, Friday. Get your test done. Have some confidence. Be aligned. Rawr, okay? Make sure you have positive attitude, right, Caitlin P? Can do this. I can do this, okay? And coming up on Monday, you guys are going to have a quiz on the stuff that we've been doing so far. So you're going to look at domain and range and functions and all that kind of stuff. Everything from today and last day's lesson. Okay, so that'll be on Monday. Worksheets are due on Monday, I believe. So, test. Make sure it's done. All old work done. I should be getting a flood of work coming in today, guys. So I think that's going to be the focus for some of you, is get all of your old work from the trig done so you can take the test, please. Okay. You have 2-week worksheets due on Monday, quiz on Monday, and then I've added on onto the site is just an extra little thing that you guys can do. Let me go, sorry. So right here, I'll make this stuff available for you guys to see in a second, but right here is just a little fun biker graphing practice activity that might help you for the quiz or just to better understand some of the stuff. And you're welcome to play whack-a-mole as much as you want, right? Whack-a-mole. Okay. As you get frustrated with some of the math, just go and start trying to beat something. Okay? So any questions? Oh, that's not good, Alexis. I hope not. That's good. Okay, so any quick questions for me? Please, I'll make everything available for you guys here in a second. And make sure you get your test done, worksheets done, math help tomorrow if you need it. Okay. All right, I think we're good. So you guys have a fabulous day. And I'll see you on Monday. Enjoy your weekend, and you'll rock the test. And make sure you're ready for the quiz and stuff. Okay, bye guys.